Okay, and on to question 12. So the length of a football pitch is 90 metres, correct to the nearest metre, complete the error interval for the football pitch. Lots of students drop the mark on this one. I think it's one of the easiest questions, but because it's so obvious in a sense, you always drop the marks. It's been rounded to 90 metres instead of to 89, or instead of to 91. So the smallest value that would be rounded to 90 instead of 89 is going to be 89.5. And the largest value that would be rounded to 90 instead of 91 would be 90.5. And the symbol has, so that reads, the length has to be greater than or equal to 89.5, but less than 90.5. And that's pretty much, whenever there's an error interval question, that's pretty much how it goes. And it's quite nicely marked. It's B1 for each. So if you think you're aiming for a mark a minute, that's a fairly quick kind of gain on time. Right, question 13, sorry. Here is the graph of, we've got a quadratic graph drawn for us. What's it going to ask us? Write down the y-intercept of the graph. I'm just double checking that's the same line. That is the same line. So the y-intercept is just that point there. So we don't need it as a coordinate. You can just state 4. For part B, write down the coordinate of the turning point. That's just where, that's the saddle of the graph. So that point there would be 3 minus 5. Use your graph to find an estimate for, and if you compare that to the graph, that is exactly the same. So all we're after is where y is 0. And y is 0 is that point there and that point there. So that looks like roughly 0.75 and 5.25. Or, yeah, I'll go for that. I'm just trying to look. Yeah, I'm going to go for that. So I'm going to say x would be equal to, I think I said 0.75, or, and I've kind of forgotten what I said. 0.75 or 5.25. Or x is equal to 5.25. Right, what does the mark scheme say? So we've got B1 for 4, B1 for the point 3 minus 5. It's M1 for, okay, that's interesting. So the mark scheme is suggesting that you get 1 mark for marking the points on the graph. So M1 for marking those 2 points on the graph. And then an A1 for the 2 values. They're suggesting that I can accept anything from 0.7 to 0.9 and anything from 5.1 up to 5.3. Right, question 14. Kieran has 13 workers he can use for a job. He knows that 6 workers take 14.5 hours to complete this job. Show that Kieran has enough workers to finish the job in less than 7 days. If I was doing this, the most straightforward way is to say if I've got 6 workers and it would take them 14.5 days to complete a job, then 6 times by 14.5 will give me the amount of worker hours, the number of worker days needed. So 6 times by 14.5 gives me 86 working days. That's the amount of work needed for the job. I've got 13 workers, so if I do 87 divided by 13, then they can complete the job in 6.69 days. Well, 6923 days, ... So will be less than 7. Will be less than 7. And we can do it with a ratio table. I find the ratio table explains it better, but it just takes a bit longer to do. I tend to, whenever I've got something like this, where we've got something that's indirect and you've got workers and days or workers and hours, or they do it a lot with hose pipes to fill a lake or something like that, I look at the amount of work done by multiplying them. And where are my marks for this? So it's saying, okay, so we've got an M1 for that, and then a P1 for that, and then a C1 for that. Right, question 15. Use algebra to prove that 1.062 reoccurring can be written as. So, got a calculator to help us here, but in theory, what we're saying is x is 1.062 reoccurring. We've only got a 1 decimal pattern, so I'm going to go 10x is going to be equal to 10.622 reoccurring. Got the reoccurring pattern happening over each other, so subtract one from the other. So 9x would be equal to, if I'll do it because it's a calculator, 10.62 minus 1.06. So when I subtract them, I would get 9.56. So x is going to be equal to 9.56 divided by 9. And then hopefully if I do that on my calculator, that gives me 239 over 225. And then if I convert that to being a improper fraction, sorry, a mixed fraction, I get 1 and 14 225ths, which is what we're asked to show. Right, marks for that are given for the method of using algebra to call x, so M1. M1 for complete method to, actually they're realistically going for an M1 slightly earlier. And then an A1 for the answer. Okay then, and question 16 then. So, use your calculator to work out, giving your answer correct to 3 significant figures. So, with these modern calculators, we can type it in just like that. So, we're going for the cube root, so shift, and then my cube root button. And then I've got 1.57 to the power of 4, plus, already got my tan in degree, my calculator in degree modes, so tan of 60, and I want to divide that by 7.2 to the power of a half. And it looks really complicated, but I don't really need to simplify any part individually. I do need to type it incorrectly though. Okay, so I typed that in the wrong place. Let's retype that. So I pressed the fraction button but didn't type it in as the denominator. So 7.2 to the power of a half. So there we go. So we're looking at you done this? Different answer. Let me just check what I've typed in wrong then. There we go. So number of errors in my typing in. So I say it's pretty straightforward typing it into your calculator, but I've made 2 mistakes in typing it into mine. So tan 60. There we go. So that's what the mark scheme says as well. I can come around and double check any mistake that you've got. If you want to grab a calculator and type it in, I'll double check it. Anyone listening to the video, I've got a couple of people in the room who are doing the paper with me. So So to three significant figures, I'm looking at 0.739. So marks for that come for, it does say, so I'm not sure my feelings on these questions because just brought a point in the room that's interesting. It's suggesting that there's a method mark for any of these seen, and then it gives you a list of numbers which are viewed as partial calculations. So if you've done that separately, if you've done that separately, if you've done the numerators separately, you can get a method mark. But it's just an A1 for the answer. So the people in the room had both done this, and I can absolutely see why, because when I looked at their calculations, I didn't spot the mistake. So they'd put the cube root on the whole of the fraction, not on the numerator. And I think that's an awkward one, because I don't know whether you'd pick up a method mark or not, which is an interesting one. I've not come across a case like that before, because their only mistake was that the square root wasn't on the whole, on the numerator, it was on the whole thing, but they'd just written down the answer. I don't know if you'd pick up a method mark or not. I think you should. It's not mentioned in the mark scheme though. But there we go. Okay, question 17. Here are two equations. Oscar says these lines are parallel. I feel like there was an almost identical question earlier in the paper. Oscar says, is Oscar correct? So to do this, I would need to rearrange this equation. I know the gradient of this one is a half. Gradient of this one would be y is equal to a half x plus 7 over 6. So that, yes, they both have the same gradient. So yes, as both have gradient of a half. I'm just guessing, but my guess is correct. I was going to say it's a method 1 mark for showing this rearranged equation, and then an A1 for this line. Yeah, and that's it. Question 18 then. First 5 terms of an arithmetic sequence. Find an expression for the nth term of the sequence. So this term sequence is going up in 6s, which means the sequence must start with a 6n. And then what do I need to do to the number 6 to get to 7? I need to add 1. So that's my nth term. For part B, the nth term of a different sequence is 8 minus 6n. Is minus 58 a term in this sequence? So that's basically, we need to work out whether 8 minus 6n can be equal to minus 58. So if I rearrange that, and how I rearrange it is slightly up to me, I'm going to say I'm going to add 58 and subtract 6n from both sides. So that's going to give me 66 is equal to 6n. Divide both sides by 6, I would get 11 is equal to n. So is it a term in the sequence? Yes, it would be the 11th. Yes, it would be the 11th. Right, marking for that question then is, it is just a B2 if you've got 6n plus 1. You can pick up a B1 mark though for 6n. And then for part B, it's a method for solving and then a A1 for yes. And they've said, yes, it is the 11th term. Right, question 19 then. Oh, I'm scrolling my 2 values, which I don't want. Right, question 19. Diagram shows the plan of Jason's garden, and then we've got 2 rectangles, we've got a right angle triangle, and we've got a sector of a circle with an angle of 90 degrees. Jason is going to cover the garden with grass seed. Each bag of grass seed covers 14 meters squared. Each bag of grass seed costs £10.95. How much will Jason need for to buy all the bags of the seeds that he needs. So if I look, and I'll do it as one sum, the total area is going to be 9 times 9 times 7, that would be the area of that one, plus the area of that one, which would be 11 times by 7, plus the area of that one, which would be a triangle where we've got a half of 11 times 7, plus the area of a quarter of a circle, so it's going to be a quarter of, or pi times by 7 squared divided by 4. So that should give me the total area of the field, of the garden. So that's going to give me 9 times 7 plus 11 times 7 plus 0.5 times 11 times 7 plus 0.25 or a quarter times by shift pi times by 7 squared. So the total area of the field should be 216.98451. So how many bags of garden seed will he need? So if I do the total area divided by 14, that's going to give me, so that value divided by 14 is going to be 15.498 ... Can't have 0.498 of a bag, so he's going to need 16 bags. So he's going to need 16 times by the price per bag, £10.95. So his total cost is going to be 16 times by 10.95. So that's going to be a total price of, as long as I've done everything right, 175 leave my calculator, 0.2. So £175.20, I believe. Let's check the mark scheme though, see whether they agree with me, and they do not. Dun, 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 dun. Do they agree with my total area? So they've got a different value for the total area. Let's just... Yes. So let me just check what I've typed in wrong. They agree with that. They agree with that. There we go. That's a fairly silly mistake. That should have been a 9, not a 7. So let's just double check that. Yeah, there we go. So that should have been a 9, not a 7. Right, so let me just clear off my gibberish. So those are the bits that I need to change. And if I can go back to that calculation, which is that one there, and then I just need to switch out that 7 for a 9. So that's my actual value, 227.9845. When I divide that by 14, I get 16.284 ... So I need to times that by 17. So 17 times by 10.95 gives me the value of £186.15. So £186.15. So the mark scheme states an A1 for that value. So it's A1 for the answer. Then we've got P1 for, oh, pen's going a bit haywire. P1 for the process to find at least 3 of the 4 areas. So that's kind of this line here. A P1 for finding the total area. A P1 for then dividing that by 14. And then the final processing method mark for multiplying the 17 by 10.95 to get your 5 marks for that question. Right, question 20. So this time we are looking at Faiza is studying the population of rabbits in a park. She wants to estimate the number of rabbits in the park. So another capture-recapture question. So my method for any capture-recapture is I put the total population as X on top. So X divided by 20, so that's the proportion that she caught, where I know that the numerator is going to be the largest number, and that's going to be equal to the ratio that were tagged, sorry, wrong way around, the number that were caught the second time and the number that were tagged. Then rearrange that, so X is going to be equal to 42 times by 20 divided by 12, which will give me 42 times by 20 divided by 12. And again, a whole number answer. Reality is, though, very rare will you get a whole number answer if you ever do this in real life. But I've not seen a GCSE question where it's not a whole number so far. So we are looking at P1 for showing one of the ratios, P1 for moving it around, and then an A1 for the 70. Should have done part B as well. This one wasn't on the previous one. So Abby is studying the population of rabbits in the wood. One day he catches 55 rabbits and finds 40 of the rabbits are marked with a tag. Abby estimates there are 50 rabbits in the wood. Explain why Abby's estimate cannot be correct. That's confusing me as a question. I know. I can't get my head around why. Is it that obvious? Explain why Abby's estimate cannot be correct because she caught more than that on day one. She caught more than that on day one. Yeah, that seems like too. Normally they will ask, what assumption have you made? It's pretty standard for a capture-recapture. What assumption have you made? What do they say? B1, for example, the sample size cannot be greater than the population size. Yeah, so we've got a C1 for that. Okay. Question 21. In an experiment, 60 students each complete a puzzle. Cumulative frequency graph shows the information about the time taken for 60 students to complete the puzzle. Of these 60 students, the least time was 24, the greatest time was 96. On the grid below, draw the distribution of the times taken by the students. Not overly interesting. Is this exactly how it appears in yours? Yeah. This is quite a popular question on A-level papers, but they normally have let me just mess around with this slightly. So if I put that in front of text, so normally they actually line it up perfectly with the cumulative frequency thing, and then you can kind of just line straight down. But I'll show you what I mean by that in a second. So the least time was, let me move this question around so my writing's covering up my bits. And it's not a massive issue by any means, but smallest time is 24, so mark 24 on there. So 20, we're going up in twos, it looks like, so 24 is going to be there. The greatest time is 96, so we're going there. And then this is kind of the reason why you have them over each other. If I've got a total of 60, then the median will be at the 30 mark, and then you can go straight down and actually carry that line onto your graph. Why in A-level papers where you're drawing it from a cumulative frequency graph, they would normally line them up. And then likewise for the lower quartile would be at 15. So 15 is looking there. So we go across 42, and then we mark it down there. And then for the final one, we're looking at 45. So 45 is going to be roughly there. And then if we go straight down, so those are my, so that's going to be what my box looks like. And again, because yours doesn't line up perfectly, you've got to read it off and then draw it on. But that's pretty much how it's going to work. And mark scheme for that then states, where are we? 3 marks for it. M1 for identifying the median and lower quartile and upper quartile from the diagram. So I'll give myself M1 there. Sorry, B1 there. For identifying it from the cumulative frequency diagram, and then it's a B2 for the correct box plot. Okay, and question 21 then. 22. Is that the last one on the paper? I thought it said at the start there are only 22 questions. Huh? Yeah. 22, here is a triangle. Work out the area of the triangle, giving your answer correct to 3 significant figures. So we've got non-right angle triangle, 2 angles and 2 sides and an angle. So we're going to be using the area of a triangle is equal to a half AB sine C. All right. I'm just going to carry on through them. So we're looking at 0.5 times by 11.2 times by 4.3 times by sine of 118. So 0.5 times by 11.2 times by 4.3, and I've missed my decimal out, times by 4.3 times by sine of 118. So I'm looking at 21.27 if I've done that correctly. I'll just, yeah, they agree with me. So I'm looking at 21.2613 ... So to 3 significant figures then we're looking at 21.3. All right then, question 23. Is that the end? It's not. That's just 24 questions. So I'm sure it said 22 on the start, but there we go. So question 23. Calculate the length of QS. So we're looking at this length here. We can't do that yet. To do that, we'd need to work out the length of that first of all. Once we've got that, we could use the sine rule, but we're going to have to work out y using the cosine rule. So we're going to say that y squared is going to be equal to 9.4 squared plus 11 squared minus BC, so 9.4 times by 11 times by cos 27. So 9.4 squared plus 11 squared minus, so the fire alarm's doing my head in, minus 2 times by BC. Right, minus 2 times by 9.4 times by 11 times by cos of the angle, so 27. Provided I've typed that in right, that should give me my value for that. I then need to square root that for my value for y, and that gives me 5.0099 ... So I'm going to leave it like that, and I'm going to apply the sine rule. Will that move up? No, it won't. Let me just rewrite that. So I'm looking at 5.0099 0.0099 dot dot dot. So y is that value, and then x over the sine of 88 is going to be equal to y over the sine of 41. So if I rearrange that, then x is going to be equal to y times sine 88 divided by sine 41, sorry. So if I multiply that value by, actually let me redo that, fraction button, the value that I last had times by sine of 88 divided by the sine of 41, close bracket, equals 7.63. Let's just double check that before I write it down. They agree with me. Yeah. So that's going to be 7.631818 dot dot dot. So to three significant figures, that's going to be 7.63. And again, in terms of mark scheme, we've got an A1 for the answer, and working backwards, an M1 for applying the sine rule, an M1 for working at this value here, and then an M1 for applying the cosine rule for our 4 marks. Right, question 24, and this is the last one, but got quite a few parts to it. Box plot shows information about sales in thousands of pounds of an online store each month. 3/4 of the data lies between 160,000 and 350,000 because these are the values for the lower quartile and the upper quartile. Adam is wrong. Explain why. It's not 3/4. It's 2/4 or a half. It would be 2/4 or half the values. This table shows information, £1,000. On the grid below, draw the box plot for this. So least value is 30, so I'm looking at 30, my starting value, lower quartile at 80, median at 170, upper quartile at 260, and upper quartile at 250. So join that into a box plot. Obviously, you do it with a ruler, and then we have to make a compare. Compare the distribution. Whenever you ask to compare distribution between two sets of data, in theory, you compare the median and the interquartile range. So let me just clear up what we've got. The names of an online store. So that's the online store, and then this is in a shop. So the online store has a greater median. So that would be my statement 1. Online store has a higher median. And I would normally quote the figures. And then you can quote the figures. I'm not going to, just because I'm in a bit of a rush now. And then the second comparison is for the interquartile range. The interquartile range, and then if we just look at the interquartile range, so we've got an interquartile range here of, and we can actually do it from the table of values. The interquartile range is 180, and then the interquartile range of the online shop was 160 to 350, which is looking at 190. So the online store has a slightly larger interquartile range. Online store has higher interquartile range. And then marks for the whole question go. Let's look. For part A, we are looking at C1 interquartile range is half the data, so C1. For the second one, it is B2 for the correct box plot, so that looks to be matching. And then your two statements for part C. The shop takes less money for sales in general since the median is lower, so one comparison regarding the median. And then 1 mark for comparison relating to the interquartile range. The interquartile range of sales for the online store is greater than the interquartile range for the sales in the shop. So that's my second C1 mark. And that brings us to the end of the paper. Final bit that I will add to the video then is if I just bring over the mark scheme. Try and bring over the mark scheme. So at the end of the mark scheme, there will be a copy of the mark scheme attached to the video. But at the back of the mark scheme, what we've got is breakdown by question, topic by question. So whichever question you particularly struggled on, you can find out how we did on that. You can find out what topic that is. So for example, if you struggled on question 7 was on sampling. So if you want to do any specific revision, that would be the area that you could look at. There are suggested mark scheme for this paper, but as it's not gone through a full round, I wouldn't really be able to put much faith in the mark scheme. So it's just shut down. I've got too many programs open. It's trying to start back up. Is it gonna? There we go. So it has opened back up. Ooh, that's interesting. Okay, so if we just quickly go to the back page again. So there we were, and then suggested grade boundaries are 74 for a 9, 70 for an 8, 63 for a 7, 53 for a 6, 40 for a 5, 26 for a 4, and 14 for a 3. Other than that, thank you very much for your time and listening to the video. If you have any questions or comments, feel free to drop them into the chat, and I will see you soon.